Hello, my amazing students. This is Mrs. A, and I love math. And tonight we're talking about finite and infinite sets, and we're on lesson 56 in your Saxon Orange Book. So, finite means bounded or limited. A lot of books will say finite is countable. Okay, so finite is countable, bounded, limited. Infinite means cannot be counted, unbounded, unlimited. Okay, so finite, a limit, infinite, no limit. It just keeps on going. Okay, so we have an example. 6, 7, 8, 9, 10. There should have been another comma in there, right? 6, 7, 8, 9, 10 is a bounded set. It ends after 5 elements, and therefore it is finite. However, 1, 2, 3, 4, 5, ... continues going in one direction forever, and therefore it is infinite, unbounded, limitless, and we could not count them. Okay, so now let's talk about membership in a set. And here we have a whole bunch of zeros, ones, and twos. And there are no other numbers besides zeros, ones, and twos. So we could describe set B as being this set because it is the set of zeros, ones, and twos. That does not necessarily mean just 1 0 and 1 1 and 1 2. But any number of zeros, ones, and twos could be in that set. All right, so if we were going to write this set of numbers as a set, we could start and say, well, I see some zeros. I see some ones. I see 1, 2. I see no threes, but I do see a 4. I see a 5. I see no 6s, but I do see a 7. Okay, so I do not see any numbers up here besides 0, 1, 2, 4, 5, 7. 0, 1, 2, 4, 5, 7. There's nothing else there. Therefore, K would be this set would describe any number of zeros, ones, twos, threes, 5s, and 7s. Threes, there's no threes. 4s, 5s, 7s. Okay. Next example, we're asked to describe these numbers as a set. So the set for this one is supposed to be set L. So we'll say L equals, and we'll do our little braces here. Okay, so I see a 7. I'm going to go ahead and start, though, with negative 13. Just because I like to do them in order, you don't have to do them in order, but negative 13, in my mind, is a better way to do it. So negative 13, 0. Okay, so I've taken care of those, haven't I? And then, oh, I've got a 1, so I'll put a 1. And then I've got the next number up would be a 7 and an 8. And we jump to 15 and then a 42. Okay, now notice that in your textbook, it does not write them in order. Okay, it does not. It writes them 7, 15, 0, 1, 8, negative 13, 42. But it is the same numbers. My brain just happens to work in order. I like things in order, and therefore it's fine for me to write them in order. But it's fine for you to not write them in order. Okay, so to me, it's easier to see what's there when the numbers are in order. Now, we have two very special symbols that we have to talk about. This one and this one. This means that something is an element of the set. This means that something is not an element of the set. Another word for element of the set is member of the set. Not a member of the set. So they both can be used. Element, member of the set. Next example, 56.3, we're asked to define A as 0, 1, 3, 5, B as 0, 4, 6, 7, and C as 1, 2, 3, 5, 7. Then we're asked a series of questions in this cool set shorthand. So is 5 a member of A? So we have to go up to A and say, yes, 5 is a member of A, so this is true. Is 4 an element of C? So we go to C, oops, C is missing 4. So we'll say that is a false statement. Is 5 not an element of B? So here's B, and 5 is not an element of B, therefore it's true. These are logical statements, aren't they? So this is the last part of the B portion. We're still talking about membership in a set. So if L is 0, 1, 2, 3, and M is 5, 6, 7, and N is 0, 1, let's talk about the truth or the falseness of these statements. 6 is an element of L, so here's L, and 6 does not belong. Therefore, 6 is not a member of L. So we would say this is false. Is 0 a member of N? So here's N. 0 is a member, so we will say true. Pretty easy, huh? In the last part of our lesson, we're talking about graphing of linear equations and rearranging equations before we graph them. So here we have an equation, but it is in our standard form. And it's more difficult to graph in standard form than it would be if it was in slope-intercept form, which is the form when you solve for y. So let's put this into slope-intercept form. So I want to get the y term on the left, so I'm going to send this guy over across the equal sign. And when I do that, it becomes a minus 3x and a minus 3x over here. So I get 2y equals negative 3x plus 4 divided by 2, divided by 2, divided by 2. Y equals negative 3 halves x plus 2. Okay, so our equation that we started with is now in standard form and easier to graph. Okay, so when we have it in this form, we know that this is the slope and that's the y-intercept, but we're going to go ahead and graph it just plugging in some easy points. Now, I like friendly points, and when I say friendly points, I mean points that will make it not be a fraction calculation. So what if, since this is a 2 in the denominator, what if I let x be 2? So I'm going to let x be 2, and I'm going to plug it in, and this 2 and that 2 will cancel. And I'll get negative 3 plus 1, which is negative 1. And that's a point that's easy to graph. So I'm going to pick another friendly point, and I'm going to pick a 4, because 4 will also cancel with the 2, leaving me with a 2 times a negative 3. So it's a negative 3 plus 2 is a negative 4. Negative 3 times 2 is a negative 6, plus 2 is a negative 4. I got the answer right, but I said it wrong. And then that's going to be 4, negative 4. And let's pick one more point. So let's pick 0. 0 would be 2. Okay, so now we're going to get our graphing board here, nice clean board, and we're going to put those 3 points on the board and more easily graph the line. So one of the points was 2, negative 1, 1, 2, negative 1. Another point was 4, negative 1, 1, 2, negative 4, 4, negative 4, 1, 2, 3, 4, 1, 2, 3, 4, about there. The next one was 0, 2, 0, 1, 2, and see if I can do this pretty good. That would be a real good graph of my line. Now, whenever I'm going to graph, don't I want to include some points? Now, I can either include the points in a grid, like my XY grid. I could put 2, negative 1, and 4, negative 4, because those were points I found. I can put them on my grid like that, and then I can graph it, or I can just label the points on the graph, but I should have my points somewhere, either in a grid or on the graph itself. So on example 6, we can see that this is not in any of our forms, is it? It's not in standard form. Standard form has the x first. Okay, it's not in slope-intercept form, but we can easily turn it into slope-intercept form, which is the solve for y form, by just adding x on both sides. Y equals x. This is a very famous line. This line is called the identity line, and it has a very cool set of points that add to it. So if I said if x is 1, then y would be 1, then 1, 1 would be a point. If x is 2, then y would also have to be 2, and 2, 2 is a point. In fact, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, negative 1, negative 1, negative 2, negative 2. They would all be points of the line. So when we go to graphing this line, we will make a little grid here, just so you can see it with the equation. Make a little bitty one. All right, 0, 0 would be a point on this line. 1, 1, 2, 2, negative 1, negative 1, and this line goes straight through 0, 0. It is also 45-degree angles here and here. Okay, so it's a very famous line. It's the identity line. It's even got a name. Okay, so this is practice problem A, and we're ready to do our practice problem. So copy it down and pause your video. We're going to express this as members of set K. So first of all, we'll say K equals, and we'll use our little braces here, okay, to denote a set. Now remember, it does not matter how many items I have in there. I only list them once in the set notation here. So there are no negatives. I like to start with 0 and then go to 1. And I just took care of those 3. And I've got a 3 and a 5. Got 2 5s, but I only put 1 in there. And then a 9. Zero, 1, 3, 5, 9. Okay, so your next practice problem, we're talking about A being 0, 2, 4, B being 0, 1, 5, 6, and C being 1, 3, 4, 6. So now we have 4 questions that we're going to give true or false to. Okay, so is 5 a member of B? So we go look at B, and lo and behold, we see 5. Therefore, we would say this one is true. Is 5 not a member of C? So here's C. 5 is not a member, so we would say this one is true. Is 0 a member of A? So here's A up here, and 0 is a member. Therefore, we would say this one is true. 3 is not a member of C, but 3 is a member of C. Therefore, we will say this one is false. So we had true, 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 false. Here is our last practice problem for lesson 56, and we're supposed to graph this on a coordinate system. So I'm going to go ahead and put our coordinate grid, but we would like to turn it around and put it in slope-intercept form, which is our solve for y form. We're going to go ahead and subtract 2x and subtract 2x over here. Notice that I offset it because those are not like terms. So that's going to cancel, and we'll have negative 3y equals negative 2x plus 6. Now that's still not in slope-intercept form, is it? The next thing I want to do is divide by 3 all the way across to get my y by itself. So I divide by negative 3, negative 3, and negative 3. So let's write my final equation down here. Negative 3y divided by negative 3 is y equals negative 2 divided by negative 3 is 2/3 x. 6 divided by negative 3 is minus 2. So here is the equivalent equation to what we started out with, but now it is in our solve for y form, which is our slope-intercept form. We're going to go ahead and make a grid plot here. So we got x and y. Let's pick friendly numbers. 0 is always a friendly number. 0 minus 2 is negative 2. 3 would be a friendly number because I don't want to be left with fractions. If I multiply this, I put a 3 in here, then that 3 and that 3 will cancel, and I'll get 2 take away 2, which is 0. What about a negative 3? Negative 3 would make this a negative 2. Take away 2 more would be negative 4, and we have 3 points. So 0, negative 2, 3, 0, and negative 3, negative 4. So negative 4 would be way down here, maybe about there. And that would be our graph. And we don't have to put points on it because we already made a grid chart. And that is the end of lesson 56. And this is Mrs. A. And may God bless your day.